Hello everyone. First, I would like to thank for you joining me here today. My name is Rachid OUCHN from Morocco. I am a PhD student in Hassan second at Casablanca. I am here today to talk about ionic liquids for direct contact membrane distillation processes DCMD. This work and under the supervision of Professor Melody Halabi. For the plan of our presentation, we will start with a general introduction of the subject. Then we will review the bibliography section. Then we will discover that in the membrane technology. After that, we will move to the experimental part to detail process as well as the results, and we will finish with conclusion. Objective. As Integrate 1. Integrate all these process to develop a strategy to produce drinking water from seawater through the use of membrane. 2. Minimize energy for desalination processes. 3. Elaboration of resistant, durable, and stable membrane. Recently, among the technique of separation and recovery of the compound within the membrane processes which are considered as means and the same time economic and ecological. Compared to other technique, membrane processes have the advantage of better respecting the quality of products compared to conventional processes. Membrane techniques have been widely studied in recent decades for the desalination of seawater. The key to these efficient and economical separation processes is the membrane. A membrane is a barrier of a few hundred nanometers to a few millimeters in thickness, which allows for the passage of certain compounds between two media that is separated. The membrane was prepared by dissolving PVDF and DMF, which continues chilling for to 11 hours at 60 degrees Celsius. Based on the phase inversion method, the glass plate was immersed in a coagulation bath of distilled water. DCMD tests were performed on a laboratory scale model and shown in figure in order to compare water flow before and after the insertion of ionic liquids into the membrane. In a Cl solution of different salinity were used as feed solution to study the durability of the modified membrane at three different temperatures. 15, 16, and 17 degrees Celsius. The DCMD the DCMD model consisted of two horizontal chambers. The movement of hot water through the DCMD model was controlled by a peristaltic pump. Permeate mass were recorded every 30 minutes and the collected data were used to calculate the water vapor flux through the membrane. The feed rate was kept constant at 1 liter per hour. Here is the infrared spectrum which shows the ionic liquids presence in the membrane matrix and therefore as you can see here the modification of the membrane before and after the addition of agent. Scanning electron microscopy image clearly show the increase in porosity after modification of membrane matrix by polysulfone and ionic liquids. It can be inferred that the condition ionic liquids improved the hydrophobicity of the membrane. The water contact angle increased from 84 for the PVDF only membrane to 110 for the PVDF modified. Therefore, these ionic liquids modified membrane can be used for seawater desalination by DCMD. Here is the kinetic model that we used to calculate the macroscopic parameters and energetic parameters. This model is based on two law of Fick's law and the ideal gas law. This figure compares the vapor flux value of the three membrane with the salinity of the feed solution of 20 grams per liter at 70 degrees Celsius. The water vapor flux of the PVDF membrane allow this value was lower than that at the modified PVDF polysilicon membrane ionic liquids with ionic liquids 4.69 10 to the power of minus 6. In order to better explain the mechanism of water vapor transport of hydrophobic membrane containing ionic liquids, the permeability, the diffusion coefficient were determined. The permeability and the diffusion coefficient increase with when the membrane matrix is modified by polysilicon and ionic liquids. The figure indicates that the percentage of salt passing through the membrane after 6 hours of diffusion has started to stabilize and 98% for the membrane modified by ionic liquids. In order to better understand the diffusion mechanism, we determine the activation parameters. The corresponding results are listed in the table. The comparison results of the three membrane indicate the transition state dependent in ionic liquids. Therefore, it can be deduced that the diffusion of water vapor occurred by association and dissociation reaction along the membrane until the vapor reached the reception phase. Conclusion: the process of modifying a PVDF-based matrix along the by polysilicon 10 by ionic liquids TBAPF6 way was carried out in these experiment to make the membrane more hydrophobic. The membrane as prepared were characterized by FTIR, SEM, and contact angle to show the modification effected by the agent added to the matrix. The flow of our water vapor through the PVDF polysilicon TBAPF6 membrane at 70 degrees Celsius. The permeate conductivity of the membrane modified with TBRPF6 remained stable and 98% after 5 hours of the diffusion experiment. With the further extension of the broadcast process, these results are encouraging if you compare them with our old study. On the main challenge of the DCMD is the waiting of the pore over time. Thanks.